Hi, welcome back. In this video, we're going to talk about the sum and difference of cubes. In the previous video, we spoke about how to factor a cubic polynomial. So we did examples that had four terms, like ax cubed plus bx squared plus cx plus d, right? There were four terms. We divided into two different groups, and we were able to factor them through the method of grouping. Well, here we're going to focus on examples that focus on just the first and the last term. What if I only have a cubic value and some other value, say cubed? If I only have two cubes, whether I'm adding them or subtracting them, how can I factor these types of polynomials, right? So it's good to get comfortable with realizing what a cubic value is. Similar to x squared, we're multiplying a number by itself, in this case, 3 times. So I would have a list of cubes here ready. So like 1 cubed is the same thing as saying 1 times 1 times 1. 2 cubed gives us 2 times 2 times 2. 3 cubed is 3 times 3 gives me 9, times 3 gives me 27. 4 cubed would give me 4 times 4 times 4, which is 64. 5 cubed, 5 times 5 times 5 would give me 125. And I can get this list going, right? I can go all the way as far as I want. Um, it's good to know what these cube values are because we're going to be recognizing what the values are they give us. Like in this scenario, 6 times 6 times 6 is 216, and then 343, and the list keeps going, right? Can I find the cube root of these numbers, right? So the cube root, say, of 64 is going to give me 4 because 4 times itself 3 times gives me 64, right? So having this list somewhere will be very beneficial in us identifying how do you find the cube root of all these. So let's do some examples. Now here's what it's going to look like, right? We're going to either be adding cubes or subtracting cubes. So we're going to end up doing examples like this, where I'm going to be adding 2 cubes, or whether I'm going to be subtracting them, right? The thing here is that I have 2 cube values. I have x cubed and 5 cubed, or x cubed and 4 cubed, which is why I recommend, right, as we look into this general formula, I recommend that you have your list handy. Can we have this list handy so we can recognize which value we're working with? So the general rule is here for addition. If you're adding them, you're going to start with addition. You're going to find the cube root of these two. Right? Here we have a times a times a and b times b times b. I'm going to use these two values to generate my entire equation of factors. Not really an equation, but my two expressions. Right? I'm going to take the two, and I'm going to, first of all, the SOAP method will tell me how to identify the signs that I'm working with. So S stands for same, O stands for opposite, and AP stands for always positive. So notice how I identify the two values I'm dealing with, and I'll do an example with numbers in a minute, A and B. I'm going to add the two because the first sign is the same. If I'm adding 2 cubes, the first sign is use the same sign. The next sign is positive because I'm dealing with, sorry, it's negative because it's the opposite sign. And then the last sign is always positive. That's what this acronym stands for. Which signs am I working with when I'm adding or am I subtracting the cubes? I just need to identify these terms, right? So here we're dealing with a cubed minus b cubed. I take the same sign first. This is the same sign. And then I do the opposite sign. And then I have the positive sign, the always positive. Now, how do I get all the other terms? Well, first you're going to add them, And then notice how we're going to end up multiplying these, right? 8 times a squared gives me a cubed. So when I take these two terms, the a and the b, I'm going to square this value. I'm going to square this value, and then I'm going to multiply them together to get the number in the middle. Now, these are general equations that you can write down, but it'll make a lot more sense here in a little bit when I start to explain them with numbers. So let's try one out. Let's start with addition. So here I'm going to be adding x cubed plus 125. Now, because it's a cubic value, I'm going to check, does this have a cube root? And I look at my list, and I notice that somewhere in here, right, we got 125. If I take the cube root, that gives me 5, because 5 times 5 times 5 gives me 125. So the numbers I'm going to be working with here is the cube root of x to the third. This gives me x, and the cube root of 125 gives me 5. Right? It's 5 times 5 times 5. So these are the two values that I'm going to be manipulating using the SOAP method. So let's start. I'm going to first start by figuring out the signs using same, opposite, always positive. So I start with the same sign. If this is a plus, I'm going to start with addition. Yeah? Whatever values that I found, x cubed and 5 cubed, I'm going to add them first. And then I'm going to change the sign. Same, opposite, right? I change it to the opposite sign. The opposite is subtraction. And then the last sign is always positive. Always positive. So I take the two terms that I found, the x and the 5, and I'm going to manipulate them to fill out this quadratic. Now I already know that x times something will give me x cubed. So this something will be x squared. At the back, I'm going to square this term, so 5 squared is 5 times 5. And then to fill the middle term, I'm going to multiply the two. 5 times x. And these are my two factors. Now notice, I'm going to try to use a different color here so that it stands out. If I were to multiply these, x times x squared gives me x cubed. And then 5 times 25 gives me the 125. If I keep doing FOIL with everything, all the combinations, right? I have to be able to do these. If I multiply all of the things together, I should end up with the original problem. Okay, let's try another one. Identify the cube root of x cubed, which is just x times x times x. And then the cube root of 64 is 4, because 4 times 4 is 16, times 4 is 64. These are the two numbers I'm going to work with. So start by filling out my general template. Same means same sign. If it's a plus, I'm going to start with plus. Opposite, always positive. If you look at the answer choices alone, this by itself eliminates half the answer choices. And now I can fill in all the blanks with these, right? I start by adding the two terms that I have. And then I take my terms and I'm going to square it. This is x squared. Over here, I get 4 squared. And then in the middle, I multiply 4 times x. I have to have the numbers without any changes, so x and 4. And then when I include the x squared, right, x times x squared gives me x cubed. And 4 times 4 squared gives me 4 cubed, or 64. And these are my factors. The only thing I really need to know is, can I find the cube root of these two, so that once I start my baseline, I can use SOAP method to plug in everything else that I'm looking for. All right, let's give subtraction a try. So in this scenario, let's do the same thing, but now with subtraction. So, I didn't write these down for some reason, but the SOAP method, we're going to repeat it for 2 examples, right? The first example will be x cubed minus 8. Feel free to pause it and give this a try, right? Find the cube root of the 2 values. The cube root of x cubed is x times x times x. And the cube root of 8 is 2 times 2 times 2. These are the 2 things I'm going to be manipulating in my general equation. So what's my general equation? Let's start. Same sign, right? This stands for same. So I start with a minus because it matches the problem. And then it's going to be the opposite. And then the last part is always positive. Let's fill in the blanks. X minus 2. We just plug them in. And then, so plug in original values, right? The cube root in here and in here. And then I square the terms. I have x and I have 2. Square the values. X squared and 2 squared. So here we're going to square the x, square the 2, and then in the middle we're going to multiply them. Multiply 2 times x. That's it. Those are my factors. I have x minus 2 times x squared plus 2x plus 4. Let's try another one. I say we got x cubed minus 64. What are my cube roots? Well, I'm going to be dealing with x and with 4, because x times x times x is x cubed, and 4 times 4 times 4. 4 times 4 times 4 is 64. Now that I have my 2 values, let's put them in the parentheses. Same, opposite, always positive, right? I compare it to this. This is the same, the opposite sign, and then the always positive. So let's plug in the numbers. I first plug in x and 4 as they are, and then I'm going to square the first term, right? Square x gives me x squared. Square the 4 gives me 16, and then when you multiply them, you get 4x in the middle. The only difference between addition and subtraction are the signs, but the method stays the same, right? Give this one a try. I recommend that you pause it and try the method, and then press play and see if you get the same thing as I do, right? So the cube root is going to be x and 3, because x times x times x is x cubed, and 3 times 3 times 3 is 27. Identify your signs. Same sign, opposite, always positive. So I plug in the x and the 3 in the first one, because I found my 2 values. And then I take those 2 values and I square it. I square this one, then I multiply them. Those are always going to be the way you find your 2 factors. Now notice how this doesn't get squared or factored even further. I don't break this down into x minus 3 times 2 other things. This is not factorable in this scenario, right? We cannot find x times x, and then here we have 3 times 3. I'm not going to be able to cross multiply and add it to 3. Or even 9 times 1, right? I won't be able to multiply the 9 and the 1 and get like 3x from it. This is non-factorable. In the next following videos, we'll talk about how do we deal with problems that are non-factorable, right? But for now, all of these are factorable. This has 2 factors. It can't go further, unfortunately, but we do have 2 factors that give me this scenario. All right, guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, I'll calculate later.